Okay, so we've modified our command to do something more interesting using information from the loaded UMI project. But a crucial part of UMI is saving things back to the UMI project, saving them to the results database so that they can be viewed and consumed and analyzed later. So let's learn how to do that. The basic way that you do that is using the UMI database, and that is, as with everything else, found within the UMI context object. The way things work is that you create a list of database objects, you populate them, and then you save them. And let's go through how that works. The first thing we do whenever we want to save to the UMI database is we create our list of database objects to save. Create a new database objects variable here. And this is going to be a list of UMI objects. Okay. Now you'll notice I get a red squiggly. If you've never done any C# development in Visual Studio before, this might be unfamiliar. This means something's wrong, but I can hover over it to see what's wrong. And it says the type or namespace list could not be found. Are you missing a using directive or an assembly reference? And the part in the parentheses is a huge clue. I, in fact, am missing a using directive, which is just a C# directive to tell my code to go look up some other code. Fortunately, this is very easy to fix. You see below the error message, it says show potential fixes, Alt, Enter, or Control period. This is a very powerful feature of Visual Studio that if you do any C# development, you will use a lot. And I'll just go ahead and do Control period, and this pops up. And it's giving me a couple of suggestions using system.collections.generic and using umi.core. So let's pick the first one. And you'll notice it added system.collections.generic up here. And now part of the red squiggle went away. And I'm going to repeat the process for UMI object. Let's go ahead and use umi.core. And it added that up here. And now that one went away too. So this just says, this line says, get me a list of UMI objects. Now this list is empty, there's nothing in it, but I can use this list to put objects in that will go to the database. And UMI object is an object that I want to save to the database. So for each of my buildings, after I calculate the occupancy, let's create a database object, okay? But before we create a database object, we need to create a data series to put in the data object. So I'm going to call it a database series. That is an UMI data series. All of data in the UMI database is in a series, even if that data just has a single data point, right? Each of this, like occupancy is not a series, there's just one value, but we still create a series that only has one item in it, just so that the way you access information is uniform. So I'll create a new UMI data series. And data series have some properties to set. Visual Studio will suggest some to me, which is helpful. So it's suggesting that I give it a name, and I will give it a name. I'm going to call it better occupancy. That's the name of my metric. This is only read by humans, so just give it something descriptive. Database series also have some other properties. They have resolutions. So if you do have a series, like an actual time series, you'd want to say whether it's monthly information or hourly information. For a single element series, like what we're calculating, it doesn't make sense to set a resolution, so we won't do that. We can set units. We will set some units because our metric has a unit. It's persons. Right? That's what occupancy is. You can leave this unset if your calculated metric is unitless. This is also just used for humans, so just give it something that will help people understand it. It's not consumed by any program, so it's not like you can get it wrong. Just you try to make it useful. And then the most important part of the database series is the actual data, right? .data. And this is a list, it's just a list of numbers. So we'll make a new list of numbers. And we'll set that list to contain just our new occupancy that we calculated, okay? So to explain this a little bit, double means number in C#, a number with a decimal point, basically. Double it means double precision, and all that really means is you can add a lot of numbers after the decimal point. but just whenever you see double, think real number, for now anyway. Now we have a red squiggle, okay? And the last error is the one that matters here. It says argument 1 cannot convert from double with a question mark to double. Now you remember I said double means number, but what's a double with a question mark? Well, when you hover over occupancy, you can see is a local variable that is a double with a question mark. And the question mark means it might not have a value set. And that can happen if the building doesn't have a gross floor area or it doesn't have an occupant density. And those in turn can happen when things are wrong in the UMI project. So if I create a building that's just flat, for example, it has no gross floor area and it's not even a solid, I can, if I work hard enough, make an UMI building that's not a solid, but it doesn't make any sense to calculate gross floor area for it. So the UMI engine just won't do it, and there won't be a value here. Alternatively, if I've somehow managed to make a building without a template assignment, which is also possible if you work at it, there's no occupant density because there's no template to get it from. So in that case, there won't be an occupancy either. And unfortunately, the UMI database won't let you store information that doesn't exist. That doesn't make any sense. So what you have to do is you have to say, well, if there's no occupancy, what do I want to do? You have a couple of choices. One of your choices is to just not do any of this at all. And another choice is to set a default value if there isn't one already set. Both choices can be good depending on your circumstances. For this workshop, I'm just going to do the second one and say, if there's no occupancy set, just use 0. And that's because this is the simplest way to write this. If you were doing this in your real module, you'd want to think yourself about how to handle these situations. But for now, we're just going to say, if there's something wrong with the building, just set it to an occupancy of 0, and we just won't worry about it. So I've created my database series. Okay, I need to take that series and I need to put it into a database object. So let's do that. You create a new database object using the UMI object.create method. And we need to give our object a name, which is just going to be the same name as the building that it was based on. We need to give our object an ID, which is just going to be the ID of the building it was based on. And we need to give it that series. If your object had more than one series, you could add them all here, but we only have one series. An example of an object with more than one series is, for example, what you get when you run the energy calculation within UMI. The energy calculation will run and it will generate heating, cooling, lighting, all that stuff. Those are all multiple series that get attached to the same database objects. But we just have one, so we'll just put it here. Now you'll see I have a red squiggle. Let's hover over it to see what the problem is. And at the end is the error. Argument 2 cannot convert from system.GUID to string. So the problem here is kind of irritating. The UMI database doesn't store IDs in quite the same way as Rhino does. They're a little bit different. Rhino uses these things called GUIDs, globally unique identifiers, and the UMI database just uses just like a general string type. So we have to convert them. It's not a big deal, but it's just something you have to remember by calling toString. So this says, hey, take that Rhino ID and turn it into an UMI database ID. And now we've created our object. So let's add it to our list of objects to save. So for each building, we're going to calculate all this stuff. We're going to create a database series. We're going to put our occupancy in the series. We're going to put our series in an object. And we're going to put our object in the list of objects. And once we've run all of our buildings, we need to save those objects. Call context. Again, UMI context is the entry point for most things you're going to want to do with UMI. We're going to store objects. And you can see Visual Studio is suggesting to me what I probably want to do. I can hit tab to just magically do that. Very convenient. Okay. And then this will save them to the database. So let's see if this worked. I've actually been running Rhino the whole time. I'm going to go ahead and close it and reload it. Go ahead and open our project. So let's run our command, and you can see it calculated the things we expected it to calculate, same as before. And let's see if these values made it into the UMI database. And you can see the database results in the UMI results viewer. And we were not storing series, right? We created database series objects, but each one only had a single item in it. So it's not really a series. So we go to the non-series tab, and there's our new metric, our new calculated simulation result. It was called better occupancy. This is the name we typed. Here's the units we typed. If I hit Y to show this particular type of scatter plot, you can see our 3 values got stored here in the database, right? And these are the values we set for them, which is pretty cool. Now, the reason to do this is that we want these to persist. So theoretically, if I even close Rhino entirely and I open it up again, when I open up the results viewer, I should see those same results even before I rerun the simulation. And that's what we're going to test out right now. So we open our project again. And we open the results viewer. And we go to non-series. And there they are. The same values there, saved to the database without us rerunning the simulation. So that's how you save to the database.